Hello everyone. In this video I am going to show you how to perform topology optimization analysis of jet engine bracket in Ansys Mechanical. So this is the Workbench platform, Ansys Workbench platform. First what we are going to do, we are going to import the geometry, right? So there is several way you can take the geometry in this platform, or you can import the geometry in Ansys Workbench. The way I'm going to do, or what I prefer to do is, so this is our CAD model. Just click here, drag and drop here. Okay. Now geometry is imported. I'm going to open the geometry in Ansys Space Geometry Editing Tool. Let it open. Okay. So it is open here. I just wanted to check if everything is fine, or if I need to do anything. Okay, I think everything is fine. Let's go to repair and extra edges, no extra edges. Okay, just click. Everything is fine. Now going back to the workbench window. Now we have the geometry here. Now we have to link the first static structure module. Like this is a predefined template. So left click, drag and drop here in the geometry, so that this geometry will be linked to this. Okay. So in the static structure module, first thing we are going to do is to enter the material details. So this is the engineering data. Double click on this and here we have the material library. Paste here. Okay. First properties, here you have the left side, here you have the property details. First we are going to feed the density. So double click on the density. Now we have the density here. Okay. We can take the density from here, 4.43 gram per centimeter cube. Since this is kg per meter cube, I'm going to change the unit gram per centimeter cube. The unit is the density is 4.43. Perfect. Now click here again. Now then this left side list will appear. Next I'm going to take isotropic plasticity. Just double click, it will come here. In isodensity, first we're going to feed is Young modulus. So what is the Young modulus? Here you can see modulus of elasticity. So 113.8 in gigapascal. So let's change the unit to gigapascal and 113.8. Next, Poisson ratio, which has no unit. Again, go back to this table, material table. The Poisson ratio is 0.342. So 0.342. Enter. Now click again here. Now we are going to put the yield strength. The yield strength, I'm going to take yield strength from this paper. It is 903 megapascal. So let's change the unit first. 903. And what is the ultimate strength? Tensile strength. This is the ultimate 950. So double click here, change the unit and 950. Enter. Okay. So material details has been entered. Now go back to the workbench window. Okay. Now double click on the model. Once you double click on the model, it will take you to the mechanical window, Ansys mechanical window. And there we are going to perform the simulations. We are going to apply the loading and bounding conditions. here we have. Okay, so this is our geometry in Ansys mechanical window. So this is the tree bar where you can do all the activities. First, expand the geometry with the geometry. Now change the material. So by default, structure still is assigned, and we are going to change the material to titanium alloy. Okay. Next, we are going to perform the meshing. So you check the enable the body selection. Click here. Now select the right click on the mesh, insert and sizing. Select the body. Now apply here so that body is selected. In element size, I'm going to change the unit from here. Click here and change the unit to millimeter. Let's put 3 mm size of element. Next, again right click, insert and method. Select the geometry and then apply here. Now change this method automatic. Okay. Now right click on the mesh and click on generate mesh. So our mesh is generated. Now what we are going to do, you can see here this is the load. I'm going to apply this 3 load. One is vertical direction, one is horizontal direction, and one is inclined 42 degree to the vertical axis. Okay. This load, how they have applied. So first I'll take the coordinates here. Select the face selection. Put the coordinates. Now select these two faces. Right click on the coordinate systems. Insert. Okay. So coordinate system is assigned here. Now to apply the force, right click. Actually, you're going to take the remote force. Take the remote force. Select these two faces. Apply. And change this global coordinate system to local coordinate system so that this coordinate system is assigned. Now in the coordinates XYZ put 0. Okay, so that remote force point comes to this coordinate origin. Okay, fine. Now to apply the vertical force, that vertical force will be negative to the x direction. It is the vertical force amount 35,586. So change this vector to components and minus 35,586. Enter. So this vertical force is applied. Next, again take the remote force, insert remote force, select these two faces, apply. Change this global coordinate system to local coordinate system. This 0, 0, 0 and 0. Change this vector to components. The force will be in this direction, horizontal direction. Amount of force is 37810. So 37810. Right. So here applied. Next is 42 degree, inclined to 42 degree. So for this one we have to take again coordinate system. Select this two face, right click this coordinate system. Now we have to rotate this coordinate system about z axis 42 degree. So here come to the coordinate system, here rotate about z axis. What about z, right? So z and here minus 42. See, it is rotated. Now again take remote force, insert remote force. Select these two faces, apply, take coordinate system 2. Okay. Now change this coordinate 0, 0, 0. Change this vector to components and it will be x directions, negative x direction here. Now let's see what is the amount of force, 42,258. 42,258. It will be negative. See the direction of the force in 42-degree angle with the vertical axis. Now we're going to apply the boundary condition. As you can see here, the boundary conditions are applied on this 4 hole. So fixed support will be applied these 4 holes. Okay, so select these 4 holes. Right click here, insert and fix it. Fine. Now let's go back to this workbench window. Now we have to link topology optimization template project, and here it is structural optimization. Just left click, drag and just drop here. Fine. Now let's go back to this mechanical window. Here we have, first we'll perform this static structure analysis. Right click, solve. Solve. Right click here, insert deformation, and right click, insert stress. Okay, now right click and evaluate all results. Here with the deformation, equivalent stress. Now coming to the structural optimization, setting, we have to change only one thing. The response constant, let's make it 30. Okay. Now right click and solve. Okay, so it is solved, and now we can check it. Let's go to optimization. Here you can see, right? You can play this. Okay. So topology optimization is done. Next we have to validate, right? So let's again go back to this workbench window and right click on the results, and then transfer to design validation system. Now right click here and update. Right click on the geometry and update. Now double click on the geometry. the structure. Now this one delete, we have this one, and right click, activate component, or activate for physics. Okay, fine. Now we have to edit this geometry, we have to smooth this geometry. First what we'll do, let's go to the facets, click on the shrink off, and here it made 0.5. Now select this and right click. Okay. Next what we're going to do, go to this sheet metal, okay, tools, yes, go to the tool, then take auto scan, select this and click. You see, now we have a smooth geometry, right? Okay. Now go to this workbench window, double click on the model. Yes. Okay, so we have the geometry here. Just okay. Delete this. Now go again and then double click here. Yes. Great. We have this file now. Okay, so now we have to validate for this geometry. First, select this, change the unit to millimeter. Coordinate system, select this, select these faces, okay, this one also, this one also, select these faces. Fine. Now generate the mesh. Mesh is generated, right? Now for remote force, we can do one thing. We can right click here, we get name selection. Okay, now you have the name selection. Now what are you going to do? Remote force. Now change this geometry selection to the name selection. Okay, now expand and select. This is selected. Okay, here 0 0. Fine. For the next also, change the name selection, 0 0. For this one also, name selection, and this coordinate system 3 2. For this one coordinate system on, for this one coordinate system on, this one coordinate 2, 0 0 0. Okay, fine, everything is fine. For fixed support, to select this face, control this face, and this face, right? Yes. Fine. For this one, you have to select the material, titanium. Fine. Okay. Now, right click and solve. So this is solved. Now we can see neutral deformation and connection. So don't go with this number because your actual stress is this. These are your actual stress. So if you can take pro 920, 830, these are the actual stress. 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 Yes. These are the actual stress. So thank you. We can follow these steps.